Today we'll be looking at the IAEA's Isotope Browser App, a free tool for finding details on radioactive isotopes and their decay mechanisms. This is the app's dashboard where we can search for isotopes. To start, I'll click on Chart. This opens up a grid of nuclides showing isotopes of every element. They're color-coded by their decay method, such as alpha in pink, beta electrons in green, and stable isotopes are given in white. We can also see others for positron emission and neutron emission and such. Let's go to the bottom of this grid, where we'll find hydrogen. It is shown as 1-H-1, very useful. And above it, we can see another hydrogen isotope given by H-2 instead, indicating it has an additional neutron. This is deuterium. Both of these are white and are stable on the charts, but the isotope above them, H-3, is known as tritium. And it's green, indicating that it decays by beta emission, which is also shown on the isotope's symbol. The half-life is shown as 12.32 years, but we can get more information by clicking on the isotope here. What we can see is the specific activity of it, the decay series. We can also see the end product that it decays into, helium-3 in this situation, a stable isotope of helium with only one neutron. Further down, we can see that we are given details about the beta emission. There's a table with the beta particle and showing its energies. So the average energy here is 5.68 keV. Next, we can look at opening up the elements using the periodic table instead. You do this by clicking on element. In this situation, it's rotated because we're in portrait view, but if you just rotated your phone to landscape, you would get it looking a bit more normal. Clicking on the elements such as strontium opens up a list of its known isotopes and their decay mechanisms. Let's use strontium-90 as an example. It's a beta emitter and it has a half-life of 28.9 years. It decays into yttrium-90 with an average beta energy of around 200 keV. Let's look at the decay products as well. So we can click on yttrium-90 here, and we can see that it has a much shorter half-life of 64 hours, which could be very useful information if you are working with strontium-90. It also decays by beta emission to zirconium-90, except the beta particles in this situation have a much higher energy of 900 keV. Further below on this list, we can see there's also a gamma and X-ray emission, with their energies and intensities also given. We can also look up the isotopes by their elemental symbol in the search bar. Typing Cn for carbon, we get a list of carbon isotopes, quite similar as if we had pressed carbon on the periodic table instead. Alternatively, we could enter a specific isotope if that's what we're interested in. Typing in 238U for uranium-238 brings up two isotopes here, which carry this name. We get 238U and 238M1U. In this situation, M means it's a metastable isotope, the nucleus is excited, and number 1 indicates the level of excitation, essentially. Let's open up this metastable isotope, and here we can see that its half-life is only 280 nanoseconds. It decays by IT, which is isomeric transition. This is a release of energy in the form of gamma rays to lower the energy state of the excited nucleus. And we can see that it decays back into uranium-238, but without the M. Clicking on the 238, we can see that it has a massively different half-life of 4.5 times 10 to the power 6 years, but it's still not stable and decays by alpha emission and potentially by spontaneous fission given by SF. Today we've gone through using the app to find isotopes, half-lives, decay mechanisms, and radiation energies. It's relatively simple to go through, look for things, and get the details that you want. Thank you for listening, and take care.